question tells us that the vehicle is travelling at 18 metres per second when the driver sees a pedestrian stepping off the pavement, and it takes 0.4 seconds for the driver to react. So the first thing we're asked for, the thinking distance. In other words, how far does the car travel during 0.4 seconds when it's still going at 18 metres per second? So that's a straightforward calculation. For the second part of part A, to find the braking distance, that's probably a bit more complicated, because once the brakes have been applied, the car will be slowing down. It will have a deceleration, or as I would prefer to think, it will have a negative acceleration. So of course this becomes a SUVAT question. It tells you the acceleration. Remember to make it negative because it is slowing down. You know the initial speed. We know the final speed, although it's not actually stated. It's about the question's about a car braking and coming to rest. So we do know what the final speed will be, and we're told what the acceleration is. Remember to make it negative. So using SUVAT, it should be possible to work out the distance it travels. And we know U, and we know V, and we know A. No information about T for the stopping part of the motion, but there's one of the equations that will do the job for us. And then for part B, it's just a case of totting up the things we've got. We know how far the car travelled while the driver was thinking. We know how far it travelled while he was braking. We know that the pedestrian was 45 metres ahead of the car initially, so you can work out where the car is in relation to the pedestrian. For part 2 is a SUVAT question. It tells you the distance it takes to brake, it tells you what the initial speed is, and it asks you to find, well, it says the deceleration. Obviously that means it's the acceleration, it's A, and we know we're going to get a negative value for it. So part A is a SUVAT question. Part B, it asks us to find what must the frictional force be. So we've already worked out the acceleration. We're told what the mass of the car is, so it's a case of how much force does it take to give a car of that mass the amount of acceleration we've already calculated. Question 3, part A, explain what's meant by the braking distance of a vehicle. But we'll leave you to do that one yourselves. If you are completely flummoxed, remember that these questions are at the end of a section of the book that's about stopping distance and braking distance and stuff. So have a look at the book if you're stuck. Part B, explain in terms of the forces acting on the wheels of a car why a vehicle slows down when the brakes are applied. So it's slowing down, that means it's got a negative acceleration, or an acceleration that's in the opposite direction to where it's moving. So you think, well, what sort of force is required to give it an acceleration that's in the opposite direction from which the car's moving? Does it require a forward force to do that, or a backward force? Thinking about that, explain in terms of the forces why the car slows down. Right, question 4. Question 4, so the frictional force on the vehicle, that's the force from the road, that's the force that would cause the vehicle to brake. And it tells you that on a particular road surface that force is 0.6 times the vehicle's weight. I think there's actually a word missing from the question. I think it should say the maximum frictional force. Frictional force can't get any bigger than 0.6 times the vehicle's weight. So the first part of the question is to find what's the maximum deceleration of the vehicle. In other words, what's the biggest acceleration? And we know it's going to have a negative sign because it's slowing down. So it tells us the mass of the vehicle. So we're able to calculate the weight of the vehicle using the information given at the top of the page. If we know the weight of the vehicle, we know that the maximum frictional force will be 0.6 times the weight of the vehicle, because that's what the question says. So if we know the maximum frictional force on the vehicle, and we know the mass of the vehicle, then we can find the acceleration. By knowing the force and the mass, we can find the acceleration. And hopefully the value you get will be the value there that you're supposed to be showing. To find part B, find the braking distance. Well, you know the acceleration, it tells you initial speed, so it's a suvac question, where we're trying to find the distance s. Where we know u, we know that v is 0 because the vehicle's stopping. We know the value of acceleration to use, so you should find the value of s easily enough.